Okay, this video will feature 3 additional examples for exponential word problems. So the first problem here says a cup of tea contains approximately 35 milligrams of caffeine. The average teenager can eliminate approximately 12.5% of the caffeine in their system per hour. If a student drinks 3 cups of tea in the morning, about how much caffeine will be in a teenager's system after 4 hours? So the key word here to tell us whether this is growth or decay is right there. That is the word eliminate. Eliminate tells us that this is a decay problem, because eliminate is in our decay list. So we would be using the equation y equals a times 1 minus r to the t, meaning that we need values for all 3 of those. Now, one of those values is extremely tricky. That is the a value. We need to be very careful here. This is kind of written like an SAT, ACT question. That is that there are actually 2 numbers that determine our a value, because 1 cup of tea contains 35 milligrams of caffeine, but the student we're referring to in this problem did not drink 1 cup, he drank 3 cups. So a would be 3 times 35, or 105 technically milligrams of caffeine. Not that we need the units. The rate is 12.5%. So again, for the rate, we need to take that 12.5 and divide by 100, because that's a percentage, and we need to convert it into a decimal. So 0.125 would be our rate. And then finally, a time. There it is right there. T is 4 hours. So then we would go and we would plug these into our equation. Y equals 105 times the quantity 1 minus 0.125 to the 4th power. So again, in theory, you could type that directly into your calculator, but these are your notes. So at least on this first example, I'm going to show the full work. So the first step would be to subtract inside the parentheses 1 minus 0.125. That would be 0.875. We are then going to take that decimal to the 4th power. So that would be 105 times 0.586181641. That is approximated off of the calculator, but I kept every digit. We do not round in the middle of a problem ever. And then we multiply that by 105, which would give us y as approximately 61.5490727. So we need to answer this question. The question was asked with a statement, full sentence and is preferable. It says about how much caffeine will there be in the teenager system after 4 hours? So we would answer after 4 hours, there will be about, very important word to have in our statement, 61.55 milligrams of caffeine in the teenager's system. Now, in terms of rounding, the reason I chose to round to the nearest hundredth is that gives me a really close approximation of the decimal. I again would accept pretty much anything within plus or minus 1 of the actual answer. So I would accept 61, I would accept 61.5, and I would accept 62. I would accept any of those answers for this question as well. Again, we need to be very, very close to the actual number off of the calculator. Let's do another one. Got 2 of them on this page. We'll do them both, and that will be the end of the video and the lesson. So on average, the population of rabbits in a park grows by 250% each month. If there are 4 rabbits in the park in January, how many rabbits will there be in the park in July? So we see the word grows. I hope that means everyone recognizes this as being a growth equation, meaning that we are going to have y equals a times 1 plus r to the t for our equation. We need an initial value for rabbits in the park. That would be the 4. So a equals 4. We need a rate. There is a 250% rate of growth. So again, we need to be careful here. R is 250%, but we need to convert that to a decimal, so we divide by 100. That is 2.5. The first time we've had a rate that's bigger than 1. And then finally, we need a time. Now, time is tricky. Time is given by these 2 words, January and July. So when we're trying to figure out the time, we need to figure out how many months there are between January and July. But we need to be very careful there because you don't count January. Let's say that we were referring to an actual date like January 5th. The first month would then end on February 5th. So no matter what day in January we're dealing with, the first month would be February. So we need to count the months from February to July. There are 6 of them: February, March, April, May, June, and July. So we have 6 months, so t would equal 6. Plug those into the equation. Y equals 4 times 1 plus 2.5 to the 6th power. So again, we're not going to show all the work this time because we have less space. We would be plugging 4 times 3.5 to the 6th power into our calculator. That is going to be a fairly large number. That is 7,353.0625. So again, we need to answer with words. In July, there will be about 7,353 rabbits in the park. Now, I realize that sounds like a lot, but also keep in mind that this problem is not taking into account what would actually happen in nature. Not all of those rabbits would live to be 6 months old. But anyway, moving on. One final problem. A new SUV depreciates at a rate in value each year by a factor of 15%. If the SUV costs $35,000 when purchased new, find the vehicle's value to the nearest cent 5 years after it is purchased. So the key word here is depreciates. That word means decay. So this is a decay problem, meaning we're going y equals a times 1 minus r to the t. The a would be the initial value of the vehicle. That is $35,000. So a is 35,000. R is this 15%, but again, we need to write that as a decimal. So we do 15% divided by 100, which would be 0.15. And the time is 5 years. T equals 5. Plug those numbers in. So y equals 35,000 times 1 minus 0.15 to the 5th power. So we plug that into our calculator. Again, what we're really plugging in is 35,000 times 0.85 to the 5th power. Which gives us 15529.68594 off of the calculator. We're going to round that to the nearest cent. So we're rounding here, which means we're going to round that 8 up to a 9. So we would say the vehicle is worth about $15,529.69 5 years after it is purchased. Hopefully, you've gone through the notes with me and even paused me and tried these problems on your own instead of just following along. You have a homework assignment as well over this that contains 6 additional problems. So, if you have any questions, make sure you bring them to class. That does it for this lesson.